Hello, everybody. Welcome to 7.3 Hyperbolas. All right, so uh, once again, just like the other previous sections, we're going to start with the chart. Okay, let's roll through it. Uh, so left side here is when two parts of the graph are facing left and right. These are facing up and down. How do you remember that? Well, if y is first, up, down. X is first, left, right. Okay. As you might notice in what I try to mention in class, a squared is always first. No matter how big a is and how big b is, a is always first. Okay? Next, some other bits of information for you. I'd recommend pausing and jotting this down. Some of these words are new, I know, like transverse axis. Uh, we'll get through what that means and what I'm talking about there. Same thing with a conjugate axis and asymptotes. They follow this form right here. Okay. All important. As you can see, there's asymptotes involved whenever you look at the graphs um, that was posted 20, 30 seconds ago. Also, instead of c squared equals a squared minus b squared, you're adding again, which makes it nice. Okay, so you're adding a squared plus b squared with hyperbolas. Let's do some problems together. So, center. We have a center at 0, 0. Now our a value is 2 and it's under x. So what I'm going to do, we're going to have points. This is going to be really hard to graph with the tools I have here. So it's going to be about, we'll call that 2, negative 2 because you're 2 away from the center. And then as you saw with this, uh, the b value is 1. So we're going to go 1 up. And also a little warning, you should do this with a pencil, okay? Because what I'm going to do is I'll be erasing, okay? So what I'm going to do is I'm going to make a box all around. And then with this box, at the diagonals, I'm going to draw a line through the diagonals. We have our asymptotes as a result. How nice. And as you see, we have vertices where my cursor is right there and right there. And I draw these parts of the hyperbola. There we go. Next, a little different story. So we have a center at negative 4 comma negative 1. Other way around. That was almost bad. Go away, go away. Negative 1 comma negative 4. Let's plot. Negative 1, negative 4, right there. And then what's our a value? We're going to have our a value is 8, and we're going to go up 8 and down 8. I have to go a little bit off the page. I apologize. We have vertices there and vertices there. What else we got? B value is 9. So I'm going to go 9 over both ways. 9 over is here. 9 over is here. And then I'm going to draw my box. There we go. And then down here are our diagonals. And then go like that. And then go up a little bit so I can draw a little better. There. Here we go. We drew your hyperbola. What I did forget to do was solve for the foci in both of them. So remember, a squared plus b squared equals c squared. You have a squared and b squared already. A squared is 4, b squared is 1. So it's going to be 4 plus 1 equals c squared. So c is going to be equal to root 5. So we're going to have just add root 5 to over here. So root 5 is about 2 over, so it's going to be right there. And so we're going to have 2 plus root 5, comma 0. And then we're going to have negative 2 minus root 5, 0. And there you have it. There's your foci, and then same thing over here. A squared plus b squared equals c squared. Add them up. Here, 64 plus 81 c squared. 145 equals c squared, and c is going to be equal to root 145 rather. So that's going to be rather large, right? Because square root of 145 is about a little over 12. So you're going to be way out here. Okay. If you wanted to write in the foci, our vertices were at negative 1 comma 4, so you do negative 1 comma 4 plus root 145, and then negative 1 comma negative 12 minus root 145. There you have it. This one right here, we have vertices and then a conjugate axis length, and that's where we get to talk about the conjugate and transverse axis, which I'll mention in a second. So halfway between the vertices is going to be your center. Center, 3 comma 4. All right, now what's going first? Since your y is the one that's changing, your y will go first. So y minus 4 squared minus x minus 3 squared. Now to figure out denominators. So distance from the center to your vertices will be your a value. That's 2. So 2 squared is 4. So 4 goes down there. Now the conjugate axis is always going to be the one we don't well, let me rephrase that. Conjugate axis refers to the b values. Okay. Transverse axis will be a. Okay. So if I'm telling you the conjugate axis length is 10, that means your b value is equal to 5. Give me 5 squared is 25. There you go. So this problem right here is going to deal with asymptotes. Okay. We'll do a lot of work with asymptotes in class so that you're super clear. First, so center between the foci will be your center. So what's halfway in between 2 and 12? Well, that's going to be 7. 7 comma negative 2. Now what goes first? Well, the x is the one that's changing, so the x goes first. So x minus 7 squared, y plus 2 squared. Now what's a and what's b? Well, how much of a change from the center to your foci is it? It's 5, right? So 5, well, excuse me, not 5. 5 is your c value. Okay, so we have our c. C squared is equal to 5 squared. Now what do we have over here? We have y equals 3 over 4x minus 29 over 4. The fact that c is 5 is going to help us out tremendously because that means your asymptotes and x squared is first, which means your slope of your asymptote is b over a. Okay, so b over a in this case. Okay, if y squared is first, it's a over b. Okay, if you don't believe me, look at the graphs. Okay, it has a slope of b over a when the x is on top. Okay, when the y is first, it's a over b. Now, how does that help us? So that means a squared plus b squared needs to be of the ratio 3 to 4. Does this work? Yes. Sometimes you will need to multiply these values by 2 because they might be reduced. But in this case, it works out because 3 squared plus 4 squared does in fact equal 5 squared. And as we know, the a value in this case is your denominator, so it's going to be 4 squared up down here, and then 3 squared down here. Giving us x minus 7 squared over 16 minus y plus 2 squared over 9. And there you have it. Appreciate you. Thanks for watching. I'll see you later. Bye-bye.